Using AI to code can feel kind of magical, right? But what if, instead of just using one single tool, you were actually conducting an entire orchestra of specialized AIs? Well, today we're going to break down a new workflow that lets you do just that, making you a way more efficient, powerful, and honestly a smarter developer.
But first, we need to talk about the coder's dilemma. Because if you're really using AI to build stuff, it's a wall that every single one of us is going to hit eventually. It's almost a rite of passage. You know the feeling. You are deep in the zone, making just incredible progress on some complex feature, really pushing the limits of what you can build. And then, right when you're about to have that breakthrough moment, bam, everything just grinds to a halt.
Yep, this right here. This simple, infuriating little message just stops you dead in your tracks. All of a sudden, your super powerful AI assistant is just gone. You're blocked, you're wasting time, and you're literally burning through expensive credits on these powerful models just trying to figure out what went wrong.
And this happens so much faster than you'd think. That whole trial and error loop of debugging, where you're asking the AI to try a fix, then another, it absolutely devours your usage limits. Before you know it, a massive chunk of your weekly quota is just, poof, gone.
So, how do we get around this? Well, the answer isn't to code less, it's to code smarter. It's about making a shift from using a single, do-it-all AI to a much more strategic, team-based approach.
And that brings us to the core idea here, the hybrid agent workflow. It sounds a little technical, but really, it's just a division of labor for your AI. So instead of one overworked genius trying to do everything, you have a whole team of specialists, and each one is perfectly suited for their part of the job. The whole thing breaks down into this really simple three-step process. First, you plan. You use an AI with a massive context window, something like Google's Gemini, to do all the heavy lifting, the research, the strategy. Then, step 2, code. You hand that detailed plan over to a best-in-class coding model like Anthropic's Claude Code to just execute. And finally, step 3, test. You use a specialized agent to find all the bugs without wasting your expensive coding token.
So you might be asking, how does this all actually work together? Well, the secret sauce is something called the Model Context Protocol, or MCP. And I love this quote because it's the perfect analogy. It's basically the USB-C for large language models. It's this universal translator that lets all these different AIs share files and context and just understand each other seamlessly. It's what lets the orchestra play in perfect harmony.
So, let's meet the band. It's time to assemble your AI dream team. For this workflow, we're going to need 3 star players.
First up, you have your planner, your strategist, Google Gemini. Its superpower is that huge context window, which is just perfect for doing deep research and mapping out the entire project. Next is the coder, the workhorse, Anthropic's Claude Code. This is the powerhouse that takes the plan and actually turns it into clean code. And finally, you've got the tester, TestSprite. Its only job is to run automated tests, find what's broken, and report back, saving your star coder from all that tedious debug. Okay, that all sounds great in theory, but let's see how this orchestra actually performs when we give it a real-world challenge. We're going to take an existing app and try to add a pretty complex new feature. The goal is something a lot of us have to do: add a full user sign-in and authentication system. You know, it's a common task, but it has a ton of moving parts that all have to work together perfectly. It's easy to mess up. So after our coder AI, Claude, finishes its first pass, we hand the code over to our tester, TestSprite. And as you can see from these initial results, it's not perfect. 2 of the tests pass, which is great, but 3 of them fail. So yeah, we've definitely got bugs. Now here's where the workflow really shows its magic. Instead of just getting a generic, "it's broken, try again" message, the tester gives us this incredibly precise, human-readable report. It pinpoints the exact problem. There's a broken connection between the authentication logic and a local database. No guesswork needed. So armed with this specific diagnosis, Claude Code doesn't have to guess or try a dozen different things. It's not running through those expensive trial and error cycles. It can go in like a surgeon and perform a targeted fix for that one exact issue. This is what efficiency looks like in action. No wasted tokens. We run the tests one more time, and what's the result? A perfect score, 100% success. All 5 tests pass. The feature is done, it's robust, and we got there without burning through our entire usage limit on blind debugging. That's a huge win. You know, this example isn't really just about building one feature. It represents a fundamental shift in how we can think about development in the age of AI.
So what's the big takeaway from all this? Well, it all comes down to specialization. Use each AI for its specific strength. By separating your workflow into those distinct phases, plan, code, and test, you can serve your most valuable resource, those expensive model tokens. You only use them when you absolutely need them, which lets you build more stuff way faster and more reliably than ever before.
And that really leaves us with a final big question to think about. As these amazing tools keep evolving, is the ultimate coder going to be an AI? Or is it going to be the human who knows how to conduct this incredible, powerful new AI orchestra? I'd love to know what you think.